In this video, I want to go over the two your turn questions that are in video 251 talking about Faraday's law. So Faraday's law told us how much EMF was going to be induced when the flux through a loop was changing. So what we want to do in these questions, in this one here, is figure out, well, is the magnetic flux through the loop changing, yes or no? So for the first question here, we see a magnetic field that is pointing out of the page, and even though it seems like it ends here, you can assume that the magnetic field is extending everywhere. So as the loop is moving to the right, is the flux through that loop changing? Remember that the flux is a measure of how much field is passing through that loop. Well, if the loop is now over here, say if the loop is now over here, right, it has moved to the right, can you see that it still has just as much field going through it as it did when it was back here? As long as this field continues forever, if it's moving to the right, it still has the same amount of field passing through it. So the field hasn't changed, the area of the loop hasn't changed, the flux through the loop has not changed. But what about this case over here? This case, this loop is rotating about this horizontal axis. So right now it has a whole bunch of field going through it. But as we saw earlier, the effective area is reduced as it's rotating. So as it's rotating, it's as though now we only have this area of the loop that is getting some field through it because it's tilted. You don't have the field going through the whole big length times width here as it's tilted. I had a better picture of that a little bit earlier. Let's take a look when we were talking about flux here, right here. Right? You can see when the loop is tilted, there is less field going through it. So that means that when it is rotating, the flux through it is changing. When this loop here is perfectly horizontal, when it's just a line, right, it's just, the loop is perfectly horizontal, then there are no field lines going through it, right? There's no flux when that loop is perfectly horizontal. When it's perfectly vertical, there's max flux. When it's at an angle, there's some flux in between. So the flux is changing. So the answer was C. Let's look at the next question. It says, consider a closed loop made of rubber and a closed loop made of copper, same size. The magnet is plunged in and out at the same rate, which gets the larger voltage induced. So most people are going to say, oh, well, obviously it's going to be the copper. But really pay attention to what the question is asking, right? The larger voltage or the larger EMF induced, right? It depends on how fast the flux through it is changing. So in this case, the flux through the loops is changing because there's a magnet that is plunged in and out. But look, it says the same rate. The field through the loops is changing at the same rate through both loops, whether it's rubber or copper. Field is changing, same rate. The area of the loops, right, the size of that loop is the same. There is only one loop for each, the number of loops is the same. So the EMF induced in both loops is actually the same because the flux is changing at the same rate. The reason most people say copper is because they're thinking about the current and not the EMF. So you know, if you've got rubber and if you have copper, that current can flow a lot more easily through copper. Copper has a low resistance. Rubber has a high resistance. So by using Ohm's law, you see that, well, if you have a low resistance, then you're going to have a high current. That's going to be for the copper. So same voltage, but copper has more current than rubber does. So those are all the questions for this section.